you, John?
Okay. All right. Hi, folks. This is John Thornton. I'm a tutor with Seeds of Literacy, and this is April 9th, and we're going to go over solving systems of equations today. So first of all, let's get these slides going. If you think of an equation as like being a balance scale, an equation really has some of this stuff over on one side and some of that stuff over on the other, and they always have to equal. So in the equations, if you're going to move them around at all, you need to be adding things to both sides or subtracting, dividing, multiplying. The idea is to keep it equal every time. So in systems of equations, what you'll see on tests is you're given two equations, each with variables x and y. The idea is to find out what the value of those variables x and y are that will work in both of the equations. And there are several ways to do that. But what we're going to do now is to go through the substitution method. That's a method that works every time, and it'll serve you well on the GED or other tests. And I don't want to get this presentation too complicated, so we'll focus on that and see if we can do enough examples so that you feel very comfortable doing that. Okay. All right. Let's try these two equations and try doing exactly that. Let me just go back one. Okay. Well, no, let's go back here. Okay, yeah. The next slide just says, how do we do this? And the way we do this is there are 3 steps. And this is something to remember. Always think 3 steps in solving variable equations. So first, you want to isolate a variable. Now that would be either x or y. And you do that by solving for that variable in one of the 2 equations. Secondly, plug the result that you get into the other equation and solve for the second variable. In other words, you'll find out maybe what x is in one equation, plug the answer into the next equation, and solve for y. Then you use the number for the second variable to solve for the first variable by putting it back into one of the equations. Okay, so 3 steps. And really, it sounds more complicated than it is, actually. But let's try this example. Let's try 2 equations, x equals 1, and 3x plus 2y also equals 1. Now, we've already isolated a variable because one equation just says x equals 1. So that x is already isolated for you. So what do we do? Step 1 is done. Step 2 is we plug x equals 1 into 3x plus 2y equals 1. In other words, into the other equation. And when we do that, we find we've got 3 times 1 plus 2y equals 1. So then we've got the answer for that we put into the next equation. The answer is 2y equals minus 2. And we got that going back to the 3y plus 2y equals 1. We simply multiply out. We got 3. We subtracted 3 from both sides. We got 2y equals minus 2. Then get the final answer by dividing both sides by 2 to get y equals minus 1. Okay, we know x was equal to 1. We were given that. And y then is equal to minus 1. So we got the answer. X is 1, y is minus 1. All righty. So to help you out a little bit, I thought I'd show you what happens if we graph those 2 equations on a coordinate plane. And you probably won't need to solve systems of equations this way in a GED, but visualizing it this way will help you understand the meaning of this solution. So on to the graph. And before we switch over, you'll see a green line. That's the x equals 1 equation. And the blue line is 3x plus 2y equals 1. And you'll see that they intersect on the graph at the solution, 1 and minus 1. In other words, x is 1 and y is minus 1. Here we go. All right, there's the graph. And if you look at the green line going up and down, that would be x equals 1. It's 1 square, or 1 over from the y-axis. And then the other equation, 3x plus 2y equals 1, is that blue line going down on a diagonal. So what we're doing when we're solving equations, in a sense, we're finding the x-y coordinates on a graph like that. Again, this is just to help you visualize it. So we'll go on to another one. Okay. Oh, I've got to go back first and ask you. Whoa. Where are we here? Oh my goodness, I'm just messing this all up. Bear with me while I go backtrack on this. Okay, yeah, next slide is, wasn't that fun? All right, on to another example. Let's try 7x minus 4y equals minus 14. And then the second equation being 2x plus y equals 11. Now, can you start thinking about how to do this? The first thing we have to do is isolate a variable, x or y, by solving for that variable in one of those two equations. We plug the result into the other equation and solve for the second variable. Then we use that number to solve for the first variable. So which one should we do? Let's take that second equation and let's subtract 2x from both sides of the second equation. That will give us an isolated y variable. Y equals 11 minus 2x. So next step, we plug it into the other equation. So if you look at the line below 2 there, that's what we're doing. That second equation is 7x minus 4y equals minus 14. So when we put 11 minus 2x in for y, we get 7x minus 4 times 11 minus 2x, all in brackets, equals 14. So we plugged it in. Then we just simply need to solve that equation. So we multiply the numbers in the brackets to start with. We got 7x minus 44 plus 8x equals minus 14. Well, pretty easy to see that we can add 44 to both sides, and we're going to get 30. And on the left side, we get if we add 7x and 8x, we get 15x. So 15x equals 30. Easy then, we divide both sides by 15, and we know that x is equal to 2. Voila. So onward. I skipped again. So our second equation was 2y plus y equals 11. So we next take that answer, x equals 2, and we put it in that equation. So in place of the x in that equation, we put 2. So it's 2 times 2 plus y equals 11. Multiplying 2 times 2, that gives us 4. As 4 plus y equals 11. So finally, subtracting 4 from both sides, we get y equals 7. So remember, we found out first that x equals 2. Now we know that y equals 7. And by golly, that's the answer. So I hope you're able to follow that. Let's try one more. Let's try minus 6x plus 2y equals minus 7. And 3x minus 2y equals 4. This is a little more complicated. But remember, going through these examples and understanding how they work, it's going to help you solve a problem like this on the GED test. And they will have a systems of equations problem on the GE test. I pretty much guarantee that. So let's go back through the steps. Let's take that second equation, 3x minus 2y equals 4, and let's first of all divide it by 3 to isolate the x variable. So we divide by 3, and we get 3x, and we move the 2y over. 3x equals 4 plus 2y, again divided by 3. So hope you followed that. That minus 2y we added to both sides to get 4 plus 2y. And that's why I have 4 plus 2y down there divided by 3. So what's the result? Well, I'm afraid it's a little messy. That's why this is a little more complicated. We're getting into fractions, for goodness sakes. Anyway, x turns out to be 4 over 3 plus 2 over 3 y's. All righty. So let's see if I can move over to the next slide without jumping. All right, I got it. So remember, x was equal to 4 over 3 plus 2 over 3y. Now, what do? We insert it into the other equation. That was minus 6x plus 2y equals minus 7. So what's the result? Well, we got minus 6 times this doggone thing, 4/3 plus 2/3 over y, plus 2y equals minus 7. So we can just crank this through. First of all, multiply the 6 times the two numbers in the brackets. So we get minus 24 over 3 minus 12 over 3y plus 2y equals minus 7. Then we can divide those first two terms by 3 to simplify them, and we get minus 8 minus 4y plus 2y equals minus 7. Then we simplify that even more by first of all adding 8 to both sides, and that gives us 1 on the right side. And we subtract 4y from 2y, and we get minus 2y. So that's minus 2y equals 1, and y equals minus 1/2. So now we plug, going back, last step, we plug y equals minus 1/2 into the other equation, and that other equation was 3x minus 2y equals 4. So here we go on the next line. The result is 3 minus 2 times minus 1/2 equals 4. So then 3x equals 3. Why? Because minus 2 times minus 1/2 turns out to be 1. We subtract 1 from both sides, and that gives us 3 on the right-hand side. So if 3x equals 3, x equals 1. So we finally arrive at the answer here. X equals 1, y equals minus 1/2. So, is that right? Let's find out. We're saying x equals 1 and y equals minus 1/2. And we find out by checking our answer, which probably you may or may not have time to do on the GED. But if you've got the right answer, it'll work in both equations. So let's see. We start with the first equation, minus 6x plus 2y equals minus 7. So we toss in x is 1 and y is minus 1/2. So it's minus 6 times 1 plus minus 1/2 times 2 equals minus 7. Well, if you got a minus 6 and a minus 1, that's going to be minus 7. So yes, minus 7 equals minus 7. So all right, let's try that on the other equation. So the second equation was 3x minus 2y equals 4. So we do that, and we get 3 times 1 plus 2 times minus 1/2, and that turns out to equal 4, because we've got 3, and then the minus 2 times minus 1/2 turns out to be a plus 1. So we got 3 plus 1 equals 4, and 4 equals 4. So by golly, yep, that checks out. So how about that? So we know we got the right answer for that one, complicated though it might have been. But that's not all. It turns out this method is also useful in solving some word problems. Now, a word about word problems. This is going to seem maybe a little complicated to you, but I hope this example will give you a good idea of how to do that. But if you're struggling with this on the GED, don't spend 2, 3, 4, 5 minutes trying to figure it out. Just skip it and come back to it if you finish the rest of the test. Also, another tip, we're just going to give you one example here. However, you can find more examples. I think there may be some on the Seeds of Literacy packets, but if you have a computer or a pad or iPad or something and go online, if you go to ixl.com, and you bring up, it'll give you all kinds of stuff, all kinds of math. You want to go to Algebra 2, and you look for systems of equations, word problems. And you can go through that and go through 4 or 5 more problems like this. And once you do that, you will for sure be, I think, find this a pretty easy way to do it. So let's go through this one first. And this is going to be the only one we show you today. 2 groups are cleaning the football stadium after a Browns game. And group 1 has already cleaned 10 rows and cleans at a rate of 9 rows per minute. And group 2 has cleaned 4 rows and cleans at a rate of 10 rows per minute. How long before each group has cleaned the same number of rows and how many rows were cleaned? Okay, so let's think about this for a minute. How do we set up an equation that captures this? The first thing to think about is what are the 2 things they're asking you to find out? One is rows, so because that x equals the number of rows. And then, the first one is how long before they clean the same number of rows. So x equals how long. I'm not sure I set it up this way. We'll find out on the next slide. But in any case, you attach one variable to how long and the other variable to how many rows were cleaned. So let's see how to do that. And you need to isolate a variable, but first you got to set up the right equation. So step 1 is to isolate the variable, but you must write a system of equations first. So let's let y equals the rows and x equals the minutes. So we can say, all right, group 1, they did the rows that they did. They're doing 9. They're doing minutes, 9 minutes, or minutes at 9 times the pace. Excuse me, 9 times the minutes plus 10. That's going to equal y for them. And then group 2, it's 10 times the number of minutes, but they've already done 4. So 9 times the minutes, they've done 10. 10 times the minutes, done 4. Both of those equal how many rows? And we're saying the rows that they've done are going to be equal. So we have to find a solution that works for both of those equations. So to get started, we've got y isolated in both equations. So we'll start with the one that says y equals 9x plus 10. And we take 9x plus 10 and we plug it into the other equation. And that's y equals 10 plus 4. So let's see what that looks like on the next slide. I can get, there we go. Oop. Oh, phooey. I'm goofing up again. Sorry for that. That's not all, folks. Here we are. 9 plus 10. We plug that in for y equals 10x plus 4. So that leaves us with 10x plus 10 equals 4. And we've got x minus x equals minus y, and x equals 6. Okay, did you see how that worked? Basically, what we did was we took, in that first 4 numbers, we took 10x and subtracted it both sides. We got minus x. And then we took the 10 on the left-hand side, and we took that and subtracted it, and we got minus. And we got, looks like we got, looks like we should have gotten anyway, we take that, subtract it, and we should get a 4. But actually, I think I'm not sure how that happened. Anyway, the answer turns out to be x equals minus 6. And if you plug it back into that equation, it'll work. So since minus x equals minus 6, then x equals 6. So we plug that into the first equation, y equals 9x plus 10, and y equals 9 times 6 plus 10, or 9, oh boy, there's a typo. No, that's right, 54. Y equals 54 plus 10. Excuse me for goofing up on that. And that makes 64. So what we're saying is in 6 minutes, the groups will have cleaned 64 rows each. So if you go back and put that into the first 2 equations, you'll find out that that checks out. And that's the answer. So that's how to do a word problem. And again, how did we do it? We first had to think a little bit about what they're asking for the word problem and make that one of them variable x and one of them variable y, and then figure out how to set up 2 equations that would, for one for each of those 2 situations, in this case, one of each of the 2 groups, and then that's what, and then get your 2 systems of equations, and by golly, having done that, you're all set. You crank through the equations and you get the answer. Okay, so I hope this helps you understand how to solve systems of equations using substitution. And remember, there are other methods, but this is a good one, and this one will serve you well on the tests. And the 3 steps are isolate a variable and solve for x or y in one of the equations. Secondly, plug that answer into the other equation and solve, and then use the resulting number to solve for the other variable. If you remember those 3 steps, you might want to write them down and try and refresh your mind for a couple of days on them. You'll be able to solve systems of equations. Hope that helps. But in any event, that's all, folks. Thanks so much for watching.